Hello, student. Come along, child. Destination unknown. Hello, student. This evening, May 8th, 2020, here in the Northern Hemisphere around 34 degrees north latitude, meaning around the city of Cerritos, California. If you were to go out at 8 o'clock at night and look in the west-northwest part of the sky, if it's clear, shortly after sunset, you'll notice a very bright light up there in the sky. That is the planet Venus, as you can see in the screenshot from Stellarium. Venus was realized to be a planet similar in size to planet Earth. And over those years, we discovered that Venus is covered with clouds because Venus is closer to the sun than the Earth and covered with reflective white clouds everywhere. It shines extremely bright in the sky. But what was it like underneath the clouds? For centuries, all we had to guide us was our imagination. And when I was a child, I had a book someplace, which I can't find anymore, that had an artist's conception of what Venus looked like. Here's the most similar image I could find to what was in my book. My book suggested that Venus was actually a tropical swamp because we didn't know what the surface was like at all. So here's artwork from some science fiction book, and it shows a spaceship from Earth that has landed on Venus. They happen to have Venus fly traps in the foreground, and you can see it's a tropical setting with birds. In fact, there was, science fiction speculation that there could be dinosaurs roaming around on Venus. The Earth orbits around the Sun, Venus orbits around the Sun. Here I've set up a little animation using STK showing the current condition as of today, and I'm going to play this forward over the course of 1 month from May 7th to June 7th. Here we go. So what you see is that Venus is passing the Earth right now as we both race around the Sun. Venus is closer to the Sun than the Earth, so it travels faster than the Earth. And what's going on in the evening sky right now is that Venus is in the western sky getting in front of us as we view the sun. So Venus is going to swing in front of the Earth, swing in front of the sun as viewed from Earth, and head off and then show up in the morning sky. It was a sign of understanding of cultures to recognize that the morning star, Venus, is identical to the evening star, that it's actually the same planet viewed from two different sides of the sun as we look up in the sky. So right now, Venus is west of the sun and is an evening star. Once it passes the sun as viewed from Earth, it'll be a morning star. And over enough time, Venus will pass behind the sun as viewed from Earth. We call that opposition. No, we don't. We call that superior conjunction. My bad. And then it will appear in the morning, it'll appear in the evening sky, and here we go again. So over the course of many months, Venus switches from being in the evening sky to being in the morning sky. And this animation is actually right now all the way up into March of next year. So I guess I set it for much longer than 1 month. I'm using SDK to give you an overview of the current situation in our solar system between the Sun, Venus, and Earth. So this is looking down on our solar system from above the North Pole, as we define it, which is the direction that the planets go around the Sun is defined as being counterclockwise as you look down above our solar system from above the North Celestial Pole. Venus is closer to the sun than the Earth, and on this scale, it's showing Venus with this purple circle, the Earth with the yellow circle, and the Earth's moon to scale is labeled there as well. What I'm going to do is zoom in on the Earth for a moment, and what you can see as I get ever closer to the Earth, now getting to scale, is that the Earth is rotating counterclockwise as you look down on it from above the Earth's North Pole. So there's the sun, and this means that for us, here comes North America. You can see South America here. This is nighttime. Right now, it'd be around midnight here in California. As the Earth rotates counterclockwise, the sun, the stars, all appear to be rising in our east and setting in our west from our point of view. So here we are coming up on sunrise, and Venus is off to the left. If I zoom back out, Venus in its orbit around the sun is off to the left, which means the sun will set first in our western sky, and after that, Venus will set. If Venus were directly in front of the sun, we would call that inferior conjunction, and that would be where Venus is switching from being west of the sun to being east of the sun. And that means Venus would be switching from being an evening star to being a morning star. Of course, it's not a star, it's a planet, but it's very bright. So I'm speeding up the animation a bit, and you can get the idea that Venus is racing in front of the sun, and it's going to be passing the Earth somewhere around the time period of late May to early June. Here's the date of June 1st. So here's the fun-filled activity that you can do. Given that this evening, if the weather is clear, when you look in the west-northwest, you can spot Venus as the very bright object in the evening sky. But did you know that you could see Venus during daylight? And there's the challenge that I put out to you. It's easy to look at Venus after the sun sets, but how early before the sun sets can you find Venus? So there's two ways to go about doing this. One is to use the information from the internet to look up the location in the sky to hunt for Venus at any given time of day. For example, today at 3 o'clock and maybe 3:02 or so, Venus will be crossing the meridian. So if you were to be facing north and looking very high up in the sky towards directly overhead, facing north with perhaps binoculars to help you, you might be able to spot Venus even in daylight. Binoculars would help. But let's say you don't have binoculars, or you're not sure which way is north, which would be sad. What you can do, but this takes a few days, is you can watch where Venus is at sunset. Like in this image here, it shows Venus as being directly above that tree at sunset. And so go out the next day, let's make it the 9th, but go out an hour earlier, and Venus will be now above the tree and to the left by 1 hour of motion. So every hour it moves 15 degrees across the sky, ignoring how much it changes from day to day. So the next day, you might be able to say, oh, I have that tree as my reference, and here I found Venus. Of course, the tree is not going to work well as it moves backwards. So you might want to find it from one position and then reposition yourself and find it relative to something else, preferably an object that's far away from you, sticking up in the sky. So find a telephone pole, find a flagpole, find the roof of a house, that you can use as a reference point where you say to yourself, when I stand here, then at in this case, 7 o'clock in the evening, when I look just past the little reference that you're using, I can spot Venus in the sky. And then, of course, the next day, do it an hour earlier. And the sun is still up in the sky, and knowing where your reference was and shifting 15 degrees per hour. Now, maybe you can back up a full hour each day. You might be able to back up half an hour and discover, oh, that's where Venus is. So there's your fun challenge for the weekend is to begin to find the planet Venus and see how early in the day before the sun sets you can spot Venus. You can do it with just your eyes, not using binoculars or telescope. And please never, ever point any optical device directly towards the sun. So if you do use binoculars, be careful as always. Don't point them towards the sun. All right. Have fun.